PowerPoint presentation, and as well as a couple of slides I want to show you. Let me go here. Okay. All right. So if you guys remember, every time you have a power, we are in the electrical power business, right? Everybody understand why you guys are here? You're not mechanical power. We're mostly into the electrical power business. We are into bringing power from the electrical utilities into buildings and design a power system, including lights, receptacles, mechanical equipment for buildings, right? Everybody understand what type of business are we in? When you bring that chunk of power from Excel into your building, the first interface between you and the utilities is called service entrance equipment. That's the first panel, not this panel. The first panel that you have and you land your conductors into that you bring from the electrical utilities is called service entrance equipment. So it's so important, guys, to understand that so-called the service entrance equipment. So that's what we're going to talk about today. There's a few requirements for the service entrance equipment, a service entrance disconnect. So when you guys, if you are to excel in this field, you have to understand the terminology that the NEC code book use as a service entrance equipment. A few things, again, terminology is so important that they use. Today, the focus, of course, on residential, but all the information that we're going to be talking about in terms of service entrance equipment, aka the first panel that you have, and you land your conductors into it, apply to all services. But the focus, like you know, it's going to be residential. Proper sizing for residential. So you brought your conductors into that meter socket, out of that meter socket into my main panel. So the whole system here, this is your service entrance equipment. That's your service entrance equipment, where you have your disconnect, your first circuit breakers, and your and you land your service entrance conductor right into here. That's called service entrance equipment. We will get into the proper size, guys, for residential, since we're doing residential. So we're going to have service conductors coming in with a raceway. How do you size these? You guys already sized this, a couple of examples for me. I tested you in test number 1. We gave you a couple of sizes, amp size, and you went to table 310.15b7, I believe, and you sized all your conductors for it. So we're going to focus on that one. Then right at the service, there is a few requirements for grounding and bonding. And Matt, my friend, right at the service, there's special requirement for grounding and bonding. I want to remind you guys, grounding and bonding is coming in the commercial industrial, and I do have a sheet that will go in details about grounding and bonding, starting with the service equipment all the way through the whole building. So, but there are special requirements for grounding and bonding at the service. The term U for ground, guys, they use it a lot. When you bring the service, when you bring in the US, here's Derek. When you bring the service, guys, in the US, the first thing when you bring your service, here's my neutral coming in here, and you land your neutral. Here's my neutral. The first thing you need to do is go ground and neutral. They call it grounding the neutral. We ground the neutral right at the facilities. Again, we will talk about grounding and bonding. When you ground your neutral, you can tie it to a ground rod. You can tie it to the water allowed to as a grounding electrode means, ground rod, the water system, the electrical, the metallic water system in your building, or U for ground, which is basically rebars buried into concrete rebars. Rebars into concrete in direct contact with Mother Earth. So that's to ground your neutral that's coming from the utility. We talked about this one. Also, there's a few things about separate building. If you are to take a feeder atom from this building into another building right there, how do you do grounding and bonding? Again, I will go through this one, guys, in details when we go to the commercial too. And withstand rating for conductors. How much current a conductor can carry under short circuit condition before that conductor turns into a big ball of fire. That's called withstanding. How much can you withstand? Somebody start pressuring you, Matt, how much you can withstand before you fall apart. That's the same thing with a conductor. How much current that conductor? Guys, when it comes to withstand, there are two factors. I can withstand, you come and push me right now, Matt, I can withstand maybe you pushing me for how long? So withstand is how much power are you pushing me with for how long? So that's the energy, right? So when it comes to withstand anything, when the conductor can withstand a current, it depends how much the current is and for how long. That's so. Remember, the how long is as important as how much. So that's your withstand capability. Okay, there's a few definitions that you have to understand when it comes to the service, guys. It will help you understand how do we bring electrical power to a building. Definition number one, you're going to see it's called service drop. These are what we call it, Matt, the power lines coming to your house. You bring the power lines. The term, we don't call them power lines. We call them service drop. The code, these are terminology from the code, service drop. So they're called overhead because they're hanging overhead. Conductors between the utility distribution system, aka the big fat fluffy transformer on the pole, and the service point. Any comments, guys, about the service drop? You're going to see it in a second in the picture. So between the transformer on the pole and the service point, which is right at the top of the mast. Then there's overhead service conductor, overhead service conductors. So service drops, then overhead service conductors. Overhead conductors between the service point and the first point of connecting to the service entrance conductor. The terminology, guys, is important, but you're going to see in a second the picture that I'm going to show you. It really defines all of them. So let's go to the service point. There is a term that's called service point, the point of connection between the facility and the service utility. That's the point of coming coupling, or the point of demarcation point. So the point where the utility brings their cable and you bring your cable and your cable meet the utility cable. That's called the service point. The service point. Let me go directly into this one because this is probably one of the most important things. So I want to highlight a few things, guys. Here is your. I want to remind you that this is your utility here. That's utility. So look at, can you guys see that one? This is my service point right at the meter. So the utility will pull their conductors right into that meter. That's my service point. See, you can see the service drop overhead. These are the conductors coming from the utility into your meter. And you can also come from underground. That's your service drop. Service entrance, the conductors between the meter and the disconnect, they're called service entrance, and from the disconnect into the panel, they're called feeders. The terminology is so important, guys, but the most important thing is the location of the service point. Where is the service point is located? Can you guys see where the service equipment, this is called my service equipment in this case. If you put your service point here, so who decided where the service point is? Anybody? Who decides where the service point is? The utility. The utility is going to tell you the service point is going to be right at the meter. Typically at the meter is the service point, or right at the transformer here. The utility point is the service point. Then that will decide what is a service drop, what is service lateral, and what is service entrance conductor overhead or underground. If you put your service point here, then overhead service, this becomes overhead service conductors, or it could be also underground service conductors coming to the meter. And then you have service entrance conductor coming in here, and also from here to here continue to be a feeder. And this continue to be your service equipment. Any comments, guys? Any questions about these terminologies that they use? There's service conductors. I can redraw that one for you. So here's my transformer coming in here. Here's my building coming in here. So my mass coming in here. So if you're coming from, and this is underground here. So if you're coming, here's my meter socket coming in here. If you want to put your service, say if you are coming underground, you're coming underground here, and all the way to the meter, and from the meter to a disconnect right in here, and from a disconnect into a panel. This is my panel, say if that's what the situation is. So, and here's what you tie to the utilities. This point, guys, it's called the service point. This could be the service point where you tie to the utility transformer. These conductor here called service, overhead service conductors. overhead service, this is underground, I'm sorry, underground service conductors. This conductor here will be service entrance conductors. And from here and this is my feeder. Now who cares? Can I get you guys to understand who cares about all this? If it's service entrance conductor or a feeder or service conductor, you own and operate. Did you guys hear me? If it's service entrance conductor or feeder or branch circuit or service conductor overhead or underground, you as an electrical contractor responsibility to install the system. Did you guys hear me? Very important. If it's service drop like this, service drop, or service lateral, they call it lateral if it goes underground, the term the utility use. These are installed and operated and maintained by the electrical utilities. That's it. Did you guys hear me? Installed and operated and maintained by the electrical utilities, which they don't have to adhere to the NEC code book, though they do when they interface with the utilities. Any comments, any questions about the definition of service point, the point where you tie your cables to the cables coming from the utilities? We'll continue to talk about this one, guys, a lot. So as we move on in the commercial industrial too, and you'll see we'll be defining them as we go through. So that's your service point. Service point, service lateral. Okay, overhead service. If you have an overhead service, which most of residential do, in the service, that will include, so here's my overhead, here's my building. You guys see the power lines coming in here, right? Tying right here. My service point is right at this point. And you're coming in here into a circuit breaker inside the building. That's my service point right at this point. You tie at the top, right? That's called service point. So first you have your service raceways and fittings. So you have to have a service raceway here with all the fittings that comes with it. You have a meter socket. You have a meter. Here's a meter here. So you have to have your meter socket. Main service disconnect means, here's my main service disconnect means that's the first circuit breaker that you land on. Service conductors between the main service disconnect means service conductors. Service entrance conductors is right here. This is service entrance conductors, service entrance conductors. Point of attachment to the utility service, to the service drop or that service point, which is right in here. This is my service point where I tie my cables with the cables coming from the electrical utilities. Any comments, any questions? I have a couple of examples, guys. You're going to see the pictures, makes it even easier. But when you talk about service, that's what you're talking about. You're talking about you need a mast, basically a pipe sitting up there. You bring the wires inside it, bring the wires inside the pipe into a meter, out of that meter into a panel that has a circuit breaker. That's very typical for dwellings. This point here is service point. The utility will own and operate this cable. You will own and operate the cables that come from this point all the way down, excluding the meter. The utilities maintain this meter because they want to know how much you're spending. Any comments, any questions? There will be more pictures, guys, that help you. But when you talk about service, that's what you're going to ask yourself. Where are the service points? So Derek, when you become a big engineer and they give you a hospital and say, now we want you to design the power system for this hospital, right? The first question you're going to ask yourself is, okay, what type of voltage do we have? So talk about the utilities right here. Let's go see what type of voltage. Do we have voltage here? So you're talking about the service coming to your building. Okay, are we coming underground or overhead? Do we have overhead power, overhead conductors or underground? Lateral conductors. So these are the questions they're going to say, where is the service point? You're going to ask yourself, where's the service point? I need to talk to the utilities. Is the service point right here? Or is it right here? And you're going to see, guys, service point for residential, typically right at the top of the mast, a lot of them. Or when you go to the project that we're using, we're going underground, and the service point is going to be right at the meter. And we're going to assume at the meter, we're going to assume right at actually at the pole. We'll show you when we'll show that when we reach it. Okay, mast type service. Mast type service. You guys have seen it all the time, that big pipe, rigid pipe that sits right here. and you bring the power lines to it. That's your mast, right? Seen it all the time if you walk around. So commonly used method of installing overhead service entrance is for dwellings is you bring it to the top of that pole. Um, Mostly in areas where this have not installed, or so that's coming from overhead. You can also coming from underground. I will remind you guys the same thing. You can come from underground. Why do they come from overhead? Cheaper. Utilities come from overhead with service conductors or service entrance conductors or service drop or typically service lateral or service drop. Can I get you guys to understand the terms that the utilities, the terms that we use to describe the power lines are service drop if they're overhead or service lateral if they're underground. That's it. Then so these are their conductors. Our conductor that tied to their conductor, we call them service entrance conductor because they bring the service into my building. In between the service entrance conductor and the service drop, there might be a service conductors if the building, if the service is big. Okay, service entrance conductor, guys, this is a special type of cable, and it's in Article 338. It talks about it. It's a like NM cable. It's another cable you see them. They bundle together two conductors with a bare conductor, two insulated conductor with a bare that they use. The utilities use to bring the power into your building. Here's the single most important thing, guys, when it comes to the service for dwelling. I will remind you. This is how we bring, this is the transformer where the utilities will provide the power for you. I want to bring to your attention very important thing is service point. Can you guys see it right here? I want to highlight this point here. And service point, I want to bring it, it seems if you're going overhead, if you're going underground, the service point is right here. Can I guys get you to understand that one? So, Derek, my friend, from this point here through the pipe all the way down, this is owned and operated by, designed and built by the electrical contractor, electrical engineers, and owned and operated by the owner of this building. Versus this cable here that you do is owned and operated by the electrical utilities. This is called your service drop. Can I get you guys to understand who owns what is so important? With the service point is right in here. Here's my service point right here. Now, if you're going underground, my service point is right in here where you tie the transformers. Then you own, then what do you own? The utilities will own and operate this area, and this cable here, all this conduit, this is you own and operate. You own and operate all the way, and from here you own and operate this one. All this system you own and operate. Can I have a thumbs up, Chad? We know what we own and operate versus what the utility own and operate. I will bring to your attention, guys, you brought the service entrance conductor came through the pipe, into the meter, out of the meter, into the service disconnect, and then we do grounding and bonding. Can you guys see that grounding and bonding that you do here? What you do here, Matt, is you take your neutral and you ground it right at the service. You take your neutral and you ground it right at the service. In the US, guys, we run a grounded neutral. So when you bring the neutral from the utility, the first thing that the code requires you to do is to ground the neutral. How do you ground the neutral? Here's my utility type transformer coming in, guys, for dwellings. The utility will ground theirs here. Here's my neutral. Here's my hot one. Here's my hot two. I'm coming. Here's my circuit breaker 1. Here's my circuit breaker 2. So these are my 100 amps panel service. Can you guys see that? Then for the neutral, I bring my neutral to a neutral bar here. This is my neutral bar. And then I have to go and provide a grounding electrode system and ground my neutral. Can I get you guys to understand this one? That's called grounding the neutral. Any comments, any questions, guys, about grounding the neutral? Any comments, any questions? Karen, does it make sense that when you bring the neutral to the building, you have to bond it and ground it? You have to bond it and ground in the neutral. Any comments, any questions? Does it make sense? Yes, no? You're going to hear me, guys, all year talking about grounding and bonding. The first thing you do when you bring the power lines, here's my transformer coming from Excel, right? Here's my transformer. We're bringing 3-wire in. You bring your neutral, you bond it to the ground. You bond the neutral to the grounding electrode system through a grounding electrode conductor. Any comments, any questions? So before you leave this chapter, guys, we have to understand a few things. Service drop, what's a service drop is, what's a service lateral is, owned and operated by utilities, what is the service point is, the point where you tie your cables to the utility cables, and it changes. It depends where, if you're going up overhead or underground, and service entrance conductors, and service conductor overhead, service conductor underground. All these terminology, service, other than service drop or service lateral, we own and operate. Other than these two. Any comments, guys? Any questions? You have to, so Derek, my friend, when you bring your cable in here, the first thing you must land it on is, so this circuit breaker is called service disconnect. Must. You have to have a circuit breaker or a fused disconnect so you can land your cables on the service disconnect. That's a requirement by code. Service disconnect. So for example, can you have a main lugs only? What's a main lugs only? As a panel that does not have a circuit breaker ahead of it. As a service panel, no, you can't. It has to have main circuit breaker, or it has to have a circuit breaker ahead of it. Any comments, guys? Any questions? Comments, questions? So important, bringing the power to the building. You're going to hear me talking about this one, guys, now and the whole year. The only difference math is going to be, we're using single phase. This system is 240/120 single phase system. We're going to be using the same concept for 480/277 and 281/123 phase system. Same concept. Okay, when you bring your power lines, and I keep calling them power lines, but they are the service drop. When you bring the service drop to your building, there is a clearances because we don't want to kill the public. You guys are in the business of protecting the public from the hazard associated with electricity, which is hazard number 1 is the shock hazard, and hazard number 2 is the arc and arc blast, arc flash hazard, and fire hazard, right? So we're going to protect the public. So these requirements directly from NDC code book, they call it clearances. When you come clearances for the power lines. As you bring the power lines, you have to have multiple clearances right here as you land them. So if you look at the first one, A, the minimum is 10 feet. So when you land your cables into the mast at the top, minimum from the bottom of that wire all the way down to the ground right here. Can you guys see that? That's minimum of 10 feet. Done. That's minimum of 10 feet. Then 12 feet. If you go, this is a driveway. If you go over a driveway, a residential driveway, or commercial driveways with voltage 300 volt or less, like 240/120, 281/120, the clearance is right here. This is 10 feet here. This is 12 feet. You go over driveways, you have to clear by 12 feet. Okay? Now, that's the second one. If you have fences, can you guys see also if you right above the fence, you have to have 10 feet right above the fence if you have a fence. So why? Because you don't want Chad to stand on the fence and grab on the power lines. So that's your A, B, C, and then you have D, 18. Can you guys see the 18 feet over your alleys in the back of your the alleys, guys, in the back of your house? There will be, if there's an alley. Or commercial streets and so forth, you have to clear it by 18 feet. So who's going to be controlling this? The utilities, most likely the utilities. So that's 18 feet. Any comments, any questions, guys, about the clearances? Man, the most important thing for us is these values. When you bring your power lines, you have to coordinate with the utilities. How can you guys control the height of the cable? Anybody can tell me? Do we have control over the height of the power pole there, the utility pole? We have no control over it. The only way we can control is this area, the mast. So if here's the building, guys, I can put a 10-foot, I can put a 1-foot mast stick off the building, or I can put 3 feet. So if you need more clearances, you start increasing the height of that mast or pipe that's going out. So be very aware of that one. When you come closer to the building, you have to have clearances, guys. Clearances number 1 is 3 feet. You can see you have 3 feet away from windows. Conductors run above. So if you're running them above, so F is conductors run above top level of the windows, are considered out of reach that window 3 clearance is not required. So you can run it right above the window, but to the side of the window here, you need 3 feet. Okay, so that's basically from the dip loop to the finishing grade. So the most important thing is that 10 foot. They always, as you tie your power lines to the mast, you have to maintain a 10 foot, as well as 3 feet away from the windows. Can you guys see this 3 feet away from the windows? You put it to the side of the window. So important, guys, that clearances when you bring your power lines if they're overhead. Any comments, any questions about these clearances? These are directly from the NEC code book, illustrated here. If I am to summarize the whole thing, 10 foot. Remember the 10 foot. You cannot go less than 10 foot for these power lines sitting on the top of your driveway or on the top of your yard or so forth. If you're going over a swimming pool, there's other clearances. We're not going to go over that one. We'll go over it when we do the swimming pool. Okay, so that's your clearances. Any comments, guys? Any questions about going overhead with the clearances that you have to maintain for the service drop as well as the service lateral? No, service drop as well as the service conductors. Service conductors overhead. Service conductor overhead and service drop are the same. The only difference is you own and operate the service conductors. The utility own and operate the service drop. That's why. The drop means utility. Service conductor means you. Any comments, guys? Any questions about that? The clearance is so important when you put these. Okay, now if you're going underground, cables installed underground from the point of connection to the system provided by electrical utilities. When you're going underground, guys, it depends who's going to provide the conductor, depends where's the service point. So let's go back into this one. If my service point is right here, so you, Derek, my friend, will be providing all these conductors and the pipe all the way up to this point. If your service point is right here, service point, right? If your service point is right at the meter, then the utility will be providing all this cable and conduit. Can I get you guys to understand that one? Service point is so important because it determines who is, when we build the system, who's sizing and providing these equipment. So in a case like this, they're telling me that the service point is right here, that this pipe, this cable, this enclosure, all provided by me. The only thing that utility will provide is what? Anybody knows what they provide here? The meter itself. Why? Because of course they trust themselves in providing the meter because they want to charge you for it. They don't trust you to provide a meter that they're gonna charge you for the consumption of the energy. Okay. All right, service lateral. We talked about service lateral. These are the underground service conductor. If the utility brings the power from underground, they use the term lateral, service lateral. That's like service drop, except underground. The conductor between the transformer of the utility and the customer's meter, typically. Service entrance conductor, the conductor from the disconnect to the point to the disconnect point to the meter, from the disconnect point to the meter. So the same thing, guys, right here. So here's my, I know this is becoming a little bit. So this conductor here, in this case, would be service entrance conductor. And the whole terminology, guys, to get you into understanding who owns what, when, and where. Okay, so look at this installation, guys. Here's my transformer, head mount transformer. I have, so up to the meter, can you guys see the line side of the meter, this cable here. This is we're using USE cable. This is my service lateral. Can you guys see that, service lateral? From the meter into that building, can you guys see that? This is my service entrance conductor, service entrance conductor. So this is my service entrance conductor. This conductor is my service lateral. Any comments, any questions? Who cares? You will be installing and owning and operating that cable, or the utility will be installing, owning, and operating this cable. So important, right? Do you think it's important who owns and operate and install these systems? So I can't emphasize enough, guys, as we move forward. You got to understand where is where's the service lateral if we're coming underground, and where's the service drop if we're coming overhead? Because then, and where's the service point? Because that's going to decide where we're going to pull your conductors to which point, as well as your conduits. Okay, so you put them here. There's also, you have to have a warning tape, guys, for your service lateral. The code requires you to put a warning tape. So you bury your conductors at 18 feet. So you bury them 18 feet buried, and right above them 12 inches. So here's my conductors. So you put your conductors here. From here to here is 18 feet, 18 inches, 18 feet, that would be a lot. And then you put a tape right at the top of it, guys, from here to here, 12 inches. So a foot. So the code requires you, as you bring your service conductors, two things. Number one, you bury them at 18 inches, direct buried cables. You dig or deeper. And then right above, then you go put the cable right above them, a foot, you put your warning tape. So if people are cutting right through it, guys, hopefully they will cut right through the warning tape and tell them you are cutting right through a power line. Though you have to call before you dig right here in Minnesota and everywhere else, right? Any comments, any questions, guys, about service lateral, service, the meter? This meter, you own and operate. The only thing the utilities will bring to you is the meter itself, the meter socket or box. You will install. You will provide this meter socket. The utilities will provide. They will decide. They will have a specification. Like Excel here will tell you, we want you to provide a 200, for example, for dwellings now, you have to have a 200 amp, 240, 120 meter socket, right? That's a minimum that you can provide. Then they will provide the meter itself. Any comments, guys? Any questions? So you look how you're coming from here, guys, then you bring your conductors into the building, right into your service disconnect means and service panel. How high the meter is going to be, this is decided by the utilities, typically 5 feet or give or take from the finished ground, the height of the meter. Any comments, any questions? Any comments, any questions? Service lateral, service drop. So that's very important. Main service disconnect means location. Now, the most important thing, Karen, for every service is a term that's called service disconnect. Means, here is the circuit breaker. Can you guys see that? This is the 200 amp circuit breaker. And these are my service conductors coming to the transformer. Here's my meter socket here. And then I'm going all the way to the transformer. Okay? Can you guys see that one? Service disconnect means that first circuit breaker is so important. They call it service disconnect means. It has to have an overcurrent protection in it. This service disconnect must be as close to the point of entering the building as practical. It could be in the inside or the outside of the building. That's service disconnect means. Nearest the point of entrance, as close to the point of entrance as practical, shall not be installed in bathrooms. Can you put the service disconnect means in the bathroom? No. Adam, here's a question for you. I'm bringing the service from this side, from the west, right? Bringing service conductors from the west, service entrance conductors. Can I put my panel on this wall? If I have the capability of putting it in this wall. You cannot. When you guys bring your conductors into a building, you have to put your service disconnect means, the first panel, right at that wall where the conductors enter. That's a major thing, because as close, I can't emphasize the word, nearest the point of entrance, nearest wherever the conductor enter. So here's my layout, here's my panel right here, guys. If my conductors are coming from here, look at that. Do I have to go right through to the panel? Can I do that? No. If your conductors, service entrance conductors are coming from here, you have to put your service panel right in here. There's some exceptions, obviously, if you cannot. Then what they do is they put them underground, directly buried underground. They don't want you to put service conductors in the building more than you need to. And the reason for this one, guys, is because service conductors are not fully protected from an overconduction device. They can create a fire hazard. Okay, so that's your service disconnect means. What is a service disconnect means? It's the circuit breaker inside the main panel. Okay, here's a good example. You're coming with service entrance conductors into this panel. Here's my circuit breaker right here, my 200 amp panel. Done. If you're to put it in this wall, you got to have a good reason for putting in this wall, not in this wall. Can I get you guys to understand that? And the reason could be because this wall there's a furnace there or something in a dwelling. So the inspector will allow you to put it on this wall as an exception, not the rule. The rule is wherever you poke through the wall to get your conductors in, that's the wall you put the circuit, the main panel is. Karen, can I get you guys to understand that concept is so important. In commercial buildings, guys, the way we solve the problem is we go underground. We bring him, if we want to put them in that wall, you bring him underground in ducts so they are not inside the building now, right? And you poke through the concrete and you come up, then you can put them wherever you want. But you can't put them overhead in a conduit. You go underground, that's, if conductors are underground under the building, they are not in the building. If there's fire inside the conduits underground, it's not going to burn the building. It's bad news though, but it's not going to burn the building. I can't emphasize this concept, guys. Okay, service entrance conductor sizing must be sufficient to carry the load that's calculated. So how do you size a service entrance conductor, guys? Piece of cake. When you guys went for 100 amp, here's my service disconnect means 100 amp, and you guys went to size this conductor, you went to 310.15B. Can everybody go, guys, there to 310.15? B7, that little table for the commercial, and was it number 1? And we use number 1 slash 2 conductors plus, of course, the neutral. Is it number 1, the size for 100 amp? Yeah. Cover, all cover. Number 4? Okay, there you go. There's mistake number 1. Number 4. So that's how you size it. And you size it based on the overconduction device, and the overconduction device is sized based on the load. How did I come up with 100 amp? You guys are the service entrance. The load calculation that I gave you, that sheet that I gave you, walked you through the other day. You size the service disconnect based on the load inside your building. And then you size the service entrance conductor based on the service disconnect. Can you guys see how everything is depends on each other? So first, you know what the load is. From the load, you size your service entrance disconnect means, the circuit breaker. And from the circuit breaker, you're going to go size your service entrance conductor. So important. You guys are going to do this 3 times with me. Commercial, industrial, and residential project. If you have a one-family dwelling, guys, one-family dwelling residence, the NDC code book in this section, it will tell you, don't you ever dream of bringing a service less than 100 amp. In the past, in the US, we used to give 60 amp services for dwellings. The minimum for a standalone one-family residence, the minimum that we use by code is 100 amp. So if your calculation came up with 50 amps, can you use 50 amps? No, 100 is 100 amp. So the minimum that you can bring to any house is what? Number 4 conductor, 100 amp service. Any comments, any questions? Any comments, any questions, guys? So that's your sizing your service entrance conductors. All you guys have equipment for sizing and guying of mass services. So the utilities also have, guys, their own requirement for the mast and guiding the mast. As you put here's my building here, and here's my pipe sitting in here, and I'm going to, here's my power line coming in here. I'm tying it all the way here. So can you guys see that? How far can you stick above the building before it becomes structurally unstable? So you might have to put a guy right here and tie the pipe to the roof of that building to maintain the structural integrity of this mast. So be very aware of that one too. Okay, utilities. Back to the utilities. Where do you want to put the meter and the meter base or meter socket, guys? Determined by the electrical utilities. Where and how the connection will be made, and the owner service conductors. So this is, the utilities will decide where the service is going to be. Like in dwellings, guys, it will be on the side of your house, through the service disconnect means, and the meter socket, and from there you power your house. Um, Side of the house, typically, again, since we're dwellings, typically of the side of the house. In a commercial industrial building, the meter, guys, might be inside the building. It could be inside the building with access, giving access to the electrical utilities to key access to access that area. The meter base, the meter socket is always specified by the electrical utilities, installed by, designed by the engineers, installed by electrical contractors. The meter socket, the box that houses the meter, the utilities have specification. For example, Excel require you for dwellings to install a meter socket rated for 200 amps, regardless of what your service is. And then they bring the meter, they put it inside it, but you will buy that meter socket, install it, design it, and install it. Can I have thumbs up, Chad? We fully understand that the socket is designed and installed by us. Okay, cool. All right. A few things, guys, about then the meter. Why do we have the meter? Because, of course, the meter is going to, that's how we're going to charge you, right? So the meters will be dealing with something called watt-hour meter. That's how we record the energy. The electrical utilities record it by watt-hour meter or kilowatt-hour meter. So you're going to hear the kilowatt-hour. That's the value, the amount of energy that you guys consume, the amount of energy that you will consume and you will be paying for. You consume kilowatt-hour. What's the kilowatt? Is the power. What's the hour? If you multiply the power by the time, it gets you energy. That's how much energy you will be consuming at your house. 500 kilowatt hour or 1,000 kilowatt hour or 2,000 kilowatt hour a month that you will be consuming. And every kilowatt hour, what do we pay here? 9 cents. Multiply this by 9 cents. That will get you how much your monthly bill would be, plus other fees that they add to it, and maintenance and what's not. Okay, here's the cost of the power, guys, in the US. So very simple. If you have 100 watt, say you have a 100 watt bulb. Here's my 100 watt bulb. How long do you want to run it, man? 100 watt. Give me a number. Hours. 5 hours? 5 hours. The cost per kilowatt hour is 9 cents. Let's make them in dollars. 0.09. Oops. 9 cents. Yeah, 0.09. So 9 cents. And why do you think we divided this by 1,000? Anybody, why did I divide this by 1,000? Because it makes a kilowatt hour. Can you guys tell me how much should I pay for 100 watt to run it for 5 hours at 9 cents per hour? Can you guys multiply this and give me the number? So 500 multiplied by 0.09 divided by 1,000. Any? The answer should be in dollars. Anybody?
4.5 cents.
Dollars. $4.50. The answer would be in dollars. Oh, did you?
0.045.
You did the whole. 4.5. Oops. So you did this one all 4.5 cents. Did we do the math right? Did you divide everything?
Yep. 100 times 5 times 0.09 divided by 1,000.
Okay. So 4.5 cents. 4.5 cents. You guys, are you sure? Somehow. Anybody? Can anybody agree or disagree with that? Got it? That's the same number? Okay, I don't know why it sounds. I guess times. Yeah, 4.5. Thank you. 4.5 cents. It just, I guess because typically we multiply this by how many days. That's what it becomes a big deal. So now times this by 30. So multiply this by 30 times 30. Now get you a buck 35. Now we have a buck 35. This bulb by itself is going to cost you a month. Now it becomes add 10 bulbs at your house. You can see how your bills start going up. Okay, so that's how we calculate the electricity. There's a couple of examples, guys, for you. Grounding and bonding. In the US, guys, we run grounding. We have to ground and bond the neutral. So grounding and bonding, again, I'm going to talk about this one, guys, later on. Here's the service that we get from the electrical utilities. Here's my neutral. They ground it here. Here's my service entrance conductor coming in. My neutral here is coming to the neutral bar, and I have to ground it. So this is inside my panel. So this conductor, guys, called grounding electrode conductor. This is called grounding electrode. When we bond the neutral here, it's called main bonding jumper. You bond the neutral. There's a term that they call it main bonding jumper. Main bonding jumper. So grounded conductor, the grounded conductor is the neutral. That here, the grounded conductor is that conductor. The grounded conductor. Bonding, so they use grounded or grounding. If it's grounded, it's connected to the ground. Grounding, connected to a ground or a conductive body that extend the ground connection. So what they want you to do, very simple, guys, without getting into the terminology. Two things when it comes to the service. Here's my service right here. Here's my neutral. Number one, they want you to ground a neutral. Very important. The neutral wire. Then they want you also to ground the box. That's what bonding and grounding is all about. Grounding the box. That's the equipment. And grounding the neutral. That's what you do at the service. You ground the box and ground the neutral. Then bonding, the conduits that you come, here's a conduit. Can you guys see that conduit right here? There's a conduit. If it's rigid, you have to bond that conduit to the ground too. And these are also tied together. The conduit, if it's metal, that's coming, bringing the service conductor, you have to bond it. Why do we bond things? Because we want to put them in the same potential. You don't want one conduit guy sitting at 0 volt and the other conduit is sitting at 50 volt or 60 volt. So in order to eliminate conduits being energized, you tie them all together with a metallic object like a wire, then you put them at the same potential. We'll talk about bonding and grounding, guys, as we move on. Ground is the earth. Here's the terminology that you need to know. Ground is the earth. Grounded conductor, this is my aka the neutral. That's it, done. Grounding conductor equipment, this is the ground conductor, the green or the bear. Ground fault, if you have a hot conductor and a ground and equipment grounding conductor, these touch each other, you got yourself a ground fault. That's called the ground fault. Ground fault path, the path here's the ground fault path, the path that goes through the hot, through the means of connecting these two together back all the way to the source. That's called the ground path. When you have a ground fault, guys, you want the ground path to be highway interstates, not Minneapolis alleys. Big, fat. So the energy will go so fast, so the circuit breaker will trip so fast. And again, we will be talking about this, guys. Grounding of electrical system and equipment, and grounding electrode. Karen, if I can get you guys to understand, that would confuse me when I was in your age, Matt. There are two types of grounding. There's grounding the system, and there's grounding the equipment. Very simple. So if you have a box like this, here's my service. Start at the service. Here's my service, right? Here's my neutral coming in, right? Here's my neutral bar. You take the neutral and you ground it. This is called grounding the system. When you ground the neutral, that's called grounding the system. Done. Then, how about the frame, the box? Now here's my circuit breaker coming in, two of them, right? Tied together, 100 amp. Now you need to go the box. Can you guys see that box? You need to also ground it. Connect it to the ground, the box itself. That's called the equipment. The box is equipment, the system is a neutral. That's it, as simple as that. Can I Not ground and neutral? Yes. Can I, there's certain application we don't have a neutral. We don't bring it. Can I not ground equipment? Yes, with some exception. The rule, guys, in the US is 90, I would say 90% of the time, your equipment must be grounded and your neutral must be grounded. Can I get you guys to understand that one? Grounded the neutral as well as grounded the equipment at this point. There is a big sheet that I give you guys about grounding and bonding that you're gonna like it at one time. Okay, bonding. Bonding is tying two metallic objects together, guys, to put them at the same potential. That's what bonding is. So there's bonding, connecting them together. Bonding and grounding also means the same thing at one time. You know, you could have a conduit. That bonding, you bond the conduit, and the conduit acts as an equivalent ground conductor too. There's a couple of bonding jumpers, guys, and I'm not going to start with these one. There's the main bonding jumper. The main bonding jumper is when you bring, here's my neutral bar, and here's my ground bar. I grounded, and this is all inside the main box. Is my service. You bring a wire from these two, the neutral to the ground. This wire is called, or could be a screw, or could be anything, main bonding jumper. When you ground a neutral, you take it to another bar, typically inside the panel, and from the second bar to the ground, that's called grounding a neutral. That wire that you tie the neutral bar, cover bar, to the ground bar inside the panel is called main bonding jumper. Main bonding jumper. Bonding of equipment. Take this. Here's a pipe coming in here, guys. I have a pipe. Can you guys see that pipe coming in here? I take my pipe with a bonding bushing. They call it bonding bushing. And you tie that pipe here, tie it to the ground bar here with a wire, right? This one here is called supply side bonding jumper, and you guys will be doing a lot of calculation for your friend Chad in the commercial industrial project about these. You're going to be sizing it. It's called supply side bonding jumper. You basically grounding the pipe. If it's metallic, how about if it's PVC? Who cares if it's PVC? We're not going to do it if PVC. So that's your bonding. Here's a couple of examples, guys. We were talking about the here's that grounding bar that we talked about. Can you guys see this is the equipment grounding conductor going to the pipe, and another one going to concrete encased electrode here. So that's how you ground the box. Your neutral, guys, will be in a bar right here. Can you guys see that? This is my neutral. And then you tie the two together. That becomes main bonding, main bonding jumper. You need, by code, you need to tie to the water pipe coming into your building. Is this my in this metal underground water pipe? And you need to have concrete encased electrodes if you have concrete encased electrodes. The code requires you to have at least one grounding electrode means. You're going to hear the word grounding electrode. A grounding electrode is a fancy name for a metallic object in direct contact with Mother Earth. A pipe, water pipe, a rod, a ground rod, 8-foot ground rod, right into, you dig it and you stick it right into the ground. It could be a big tank, metallic tank in the ground. That could be a grounding electrode, they call it. It could be the rebars, concrete encased rebars, bars inside the concrete in the foundation of the building. That's an approved. And then the secret book guys have a list of these things approved. We will go into that one when we go to grounding and bonding. But for the time being, that's what you need to know. That's how we ground the neutral and the equipment. Can you guys see that also the equipment here is bonded? The box itself is grounded. So right at the service, we ground the neutral and we ground the what? The equipment, the box. Ground the neutral and we ground the equipment, the box. Bonding, bonding guys, if you have, here's a good example of bonding. You have a water, you have a gas pipe above ground. Gas pipe above ground, typically we bond them to that water. So why do we bond them to the water? Because if you have an accidental contact between a hot and the gas pipe, could it happen when you guys, do you see the gravity of the situation as you're designing a building that's going to live for 50 years? Can you predict the people's behavior in 50 years? Every building that you design, can you predict how people are going to behave in this building for 50 years? We can't predict the people's behavior for 50 minutes, let alone 50 years. So what you need to do then, so somebody could tamper with this equipment or an accident could happen where a hot conductor 120 touches the gas line. Now, if it's not grounded, this becomes sitting at 120 volt and this is 0 volt. 0 volt. Now here's your friend Chad coming accidentally, goofing around. Could it happen 50 years? Remember, you're talking about a whole 50 years of people's behavior in houses and buildings. So put one hand on another hand. So this is what happened. Now the current is going right through his heart here and all the way to the other end. Now, this is what's going to happen to your hair. And you're going to join the Lord so fast. This is the perfect, they call it the perfect shock. Why? It goes through the heart. It stops your heart. That's what you're trying to prevent when you bond the equipment. Can you guys see that? Now, if you put that wire here, guess what's going to happen? Now, this is at 0 voltage. This is at 0 voltage. What happens when you put a 120 volt and 0 volt together? Short circuit. That's ground fault. That's called ground fault. This Mr. Fuse here will say, you can't do that. That's a cliff. You got me into a cliff. Now, that's a huge amount of current. That's ground fault. You force them to go from 120 to 0, ground fault. This becomes very high, and long story short, this will open before Chad joins the Lord. Is that a novel idea that protect the public from being electrocuted? That's electrical shock, the shock hazard. And think of any place in this building or in a house that does not have a 120 somewhere. 50 years. For 50 years, the people are going to be behaving in these rooms. That's our job, is to protect the people by bonding these equipments. Gas lines and so forth. And that could be anything. Could be see the grid here, right? The grid above your head. Could this grid be energized? Yes. So what do they do with the grid? They bond it. That grid will be at one time bonded to the equipment grounding conductor. So if that grid is to become energized, the circuit breaker will trip accidentally. Okay, now if you're to protect, guys, what they do sometimes for the grounding electrode conductor, they protect it with an armored grounding electrode conductor. They put an armored on it. And we will talk about this one, guys. Here's my pipe. Look what they do. If you have a pipe like this, and you put an equipment grounding conductor right into it, this is my grounding electrode conductor. You're required to bond at both ends, because tests have shown that the pipe will carry most of the current, not the conductor, the ground fault current. The ground fault current. So you have to bond both ends. We'll talk about this one in details, guys. Detached buildings. We'll talk about grounding and bonding with detached buildings. So I'm going to summarize it with very simple thing. Here's a house. Here's my house. And here's my detached big fat garage. This is my garage. And I have my service coming in here. My service disconnect means I took a circuit all the way to here. This is a 60 amp brand circuit. Can you guys see that? I have to land it into a circuit breaker right in here. So if you have a feeder feeding a separate building, this is the rules. Rule number 1, you have to have a disconnect. Can you guys see that? Disconnect. Circuit breaker, must. Rule number 2, you have to have a grounding electrode system. So you have to go there, dig a ground rod right next to the second building, and ground the box, only the box, with that ground rod. Can you guys see that? And number 3, you have to pull, in residential, you have to pull 3 wires. 3 wires. These will be 2 hots plus neutral. I'm sorry, 4 wires. You need 4 wires. 3 hots, 2 hots plus neutral plus ground. You have to pull an equipment grounding conductor with it. These are the rules for feeding a separate building from a building that has a service. Can I get you guys to understand that one? Rule number 1, You have to land in a disconnect. Rule number 2, you have to create a grounding electrode system, ground rod, drive a ground rod there, tie it to the box. Rule number 3, you have to pull an equipment grounding conductor. So if you have two hots in dwellings, there will be two hots, neutral, and a ground. Any comments, guys? Any questions? The exception for this one is if you have just a branch circuit going there. If you have a branch circuit going in there, then you don't have to have a panel, and you don't have to have a grounding electrode system. You still have to land on a disconnect though. Any comments, guys? Any questions for the second building? That's how you do. That second building could be a building fit from Dunwoody here, or could be a garage. In a dwelling, it will be a detached garage. A detached garage. So if it's a branch circuit, multi-wire branch circuits, you don't have to do grounding. Only if it's a feeder. That rule that I just talked to you, if you're taking a feeder. If it's just one branch circuits, you don't have to do that. Any comments, guys? Any questions? Any comments? Any questions? I'm going to give you 5 minutes, and I have a couple of pictures I'm going to show you, and then we'll call it a day. Thank you. So just, Anna, my friend, just a quick reminder. We talked about this one, guys. What I want to emphasize is the service point. When you do, wherever you put the service point, that will decide if it's going to be an overhead service conductor, if it's going to be an overhead service conductor or underground service conductor, or if it's going to be a service drop or service lateral. Can I have thumbs up, Chad? We decide wherever the service point is, we'll decide if these conductors, the same, look at that, the same conductors are overhead service conductors or service drop. And these two are owned and operated by the utility. These two are owned and operated by owner. Okay. Any comments, guys? Any questions about that? So that's what I want to, we talked about this one, the service. We talked about these. Here's a couple of things that I would like you guys to be aware. When you put your mast, you have to do some, in order for your mast to be structurally sound, so they have to have some certain supports. I believe it's 18, if it's more than 18 inches, then you have to support it. If this is more than 18 inches, then you have to get into the support. That's structure, right? That utility is required to do that. So be aware as you put your mast. There's a lot of hardware involved in it, guys. All the hardware that involved into the connection, all the hardware that involved into mounting this structure. This is typically rigid metal conduit that we use. When you mount a rigid metal conduit to a house, these are heavy equipment. Have anybody ever done that? And the anchoring mechanism that you have to do, you have to be very careful what type of anchors you use. Otherwise, it's going to tip with wind and rain and all this good stuff. So just be aware of that one as you design system. We talked about clearances, guys. If you bring the service conductors over the building, can you guys see that? You have to maintain an 8 foot. If it's sloped, they allow you 3 feet. If it's sloped, can you guys see that? A sloped roof, 3 feet. If it's flat roof, 8 foot clearances. 8 foot clearances. So that's what we do in terms of this is maximum but look at the voltage here. The voltage is 300 volt or less, so that will cover your 208/120 volt system or 240/120 volt single phase system. 240/120 single phase system. So that's what would that cover. Any comments, guys? Any questions? Now, what's in it for you? I know you guys are not electricians to be your designers. You're going to be a project manager. You can check and inspect your work before you put it. Imagine putting all this stuff at them, and at the end, the inspector come and say, "Oops, nope, go raise it up." You're lost on this job, right? So if you know all these rules and regulations, you'll be a better. When you do drafting at Michette Cooley Erickson, they're not going to draft that one. But when you become a project manager at Parsons Electric and Hunt and Egan, that's what you're going to be involved in. Knowing this will make you a better project manager, more productive, making more money for the company. Hardware. You guys will do estimating with Chad. All these are hardware you're going to live and die before you know all the hardwares. But these are the hardwares that they use to support the mast. That's a huge, heavy thing. Wind will shift it, bust it. So you have to use more robust hardware and anchoring mechanism. Um, we talked about the low voltage system, guys. Can you bring a phone line or cable TV and anchor the cable TV to the mast, to the electrical mast? Violation of the code. You can't. Anybody knows why? Because you don't want the people climbing in there to fix their phone lines and cable TV and killing themselves. So that's a no-no. We talked about the clearances, guys. I want to emphasize all the clearances. My major one is always the 10. That 10 foot right here, guys, right here or right here above the fence is the single most important clearances. Of course, over the driveways and over alleys, 18 and 12 is also another clearances. So you gotta be, and also away from windows, 3 feet away from windows is another important clearances. Who cares? You're a project manager and you're going to be managing these projects. You better understand these rules before your electricians go there. So you will be the inspector before the inspector shows up. What I show you guys is what the inspector are going to be looking when they come and inspect your work. Does that make sense? Am I driving that point clear to you guys? So that's why we care too much. Here's your service. Let's look at this one. Is really cool. Remember that service point that we were talking about, guys? Here's my service point right here. These are overhead service conductors. These conductors are overhead service conductor. Service entrance conductors. Can you guys see that? These are the wires that's coming in here. Service conductors. So that's your service conductors. Can you guys see the neutral? Here's my neutral. I want to emphasize. I'm going to use maybe the green here. Here's my neutral coming in here, all the way, coming up to this point. Can you guys see what we do for the neutral? We bond the neutral to the enclosure, and we bond the conduits also to this, and then from here we go to the ground. That's where you bond the neutral to the box. And you ground the neutral and you ground the box. And the pipe, can you guys see that pipe here? That's bringing the power in. If it's metallic, you bond it too. So a couple of names for this. This is called grounding electrode conductor. The bonding here, this is called main bonding jumper, when you bond the neutral to the frame of that box. This wire is called supply side bonding jumper. Supply side bonding jumper. So important because based on the name, you'll be sizing them. Again, guys, you will hear a lot about this as we move forward in the commercial. So that's so there's a lot of rules and regulations when it comes to it. So be aware of that. Here's if you're using cables. If you're using cables, I've never seen a cable. You have a special hardware that you're going to use with. This is using, instead of using conduits, can you guys see that they're using a cable coming in here with special hardware all the way through? Same thing, service entrance with a special hardware that have to go through it. We talked about this one, guys. When you the type of wiring they use is USE. These are conductor rated to be buried underground. When you bury them, you have to have that caution buried electric cable, that tape that they put there. Caution buried electrical cable. So as you dig, you're not supposed to dig before you contact all utilities in Minnesota and everywhere else, right? But say if you do, hopefully you hit that wire, that one here first, and you cut through it and say, oh, electrical or electrical line before you cut right through the lines and kill yourself. This is that's 2 feet. The way it goes, first it goes the cables here, 8 minimum. Now we're talking about minimum here, 18 inches here, and then the tape will be at, they put your tape at a foot, 12 inch. A foot above the cable. So you put your cable, bury a foot of dirt, put the tape, and then continue burying. When you put a foot here, that will leave you what, with 6 inches, right? 6 plus a foot, 18. So from here to here will be 6 inches. Does that make sense? For a total of 18. Now you can go 24 if you want to. That's a minimum, remember. Minimum. Any comments, guys? Any questions about that? Comments, questions? So that's and all this is coming from this table, 300.5. It will give you the burial table for all the cables that you need to do. Okay, we talked about, guys, when you put your service, it has to be at the same wall. You poke through the hole here, the panel must be here. Very, very important, with very few exceptions. Very, very few exceptions. So it's very important. Here's your panel, guys. You probably have seen panels. So you're going to have your neutral bar, your ground bar right here. You bond them together if you're at the service. Then you can you bring your two huts here and your neutral. I don't know if you guys can see that neutral coming in right here. You land your neutral here. You put your hut one, hut two, neutral. Then the neutral. So that will be your neutral, and then you bring a wire from here to the neutral bar if this will be your neutral bar. If it's at the surface, then you bond that neutral into the box. It will be bonded to the box. So, but that's what you get. This is so important, guys, because this is how your panel is going to be located. And I told you about this one in a dwelling. I'm going to zoom a little bit onto it. This is how they label the panels. Here's your 200 amp panel. It will be always labeled 1, 2, 3, 4. This is even. This is odd. Very important. So when you say circuit 1, all the odds are going to be in the left, all the even on the right. When you need 240, if your load is like water here is tied to these 240, these are tied together. They're always adjacent evens or adjacent odds. Here's my water pump tied to these together, adjacent even or adjacent odds. That's how you get 240. You will never get 240 from 1-2 circuit. So when you say 1-2, look at this. 1-2, this is hot 1. This is also hot 1. This hot 2, hot 2, hot 1, hot 1, hot 2, hot 2. That's how it repeats itself. Later on, the way they build the panels, it becomes phase A, B, C, A, B, C, and go all the way through. By doing it this way, guys, you're always guaranteed every 2 circuit breakers next to each other. If you tie them together, you can get 240. Can I get you guys to understand that's how they make them? Because when when I told you guys, like for the water heater, say circuit 1 and 3, not 1 and 2, or 3 and 5, or 2 and 4, 2 adjacent odds or 2 adjacent evens to get you the 240. Can I have thumbs up, chat? Because you can't believe how many times we reach a commercial project and I see students circuiting a 3-phase load and they're using 1, 2, 3 as the 3-phase. 1, 2, 3 will never give you 3-phase. 1, 2, 3, 4, 5. It has to be 1, 3, 5 to get you 3-phase. Does that make sense? Very important. The odds and the evens. That's how they make it. So then you can take 1 circuit breaker with the neutral, get you 120. 2 circuit breakers with or without the neutral can get you the 240. Okay, here's your equipment. And then at the end, they have 2 bars here. 1 for the equipment, 1 for the ground. And if it's a service, they bond them together. So this is very important, guys. 115. Main lugs only. This one has main lugs only. Can you guys see the difference between this one? This has circuit breaker at the top. That's have to be service, right? The sub panels, can you guys see a circuit breaker here? No, it doesn't have to have a circuit breaker because the circuit breaker for this panel, for example, have no circuit breaker. The main for it is sitting down in a different panel. So you can't believe how many times we reach a commercial project and people still don't understand what MLO is. What's MLO? Main lugs only. What does main lugs only mean? No circuit breaker. So now if you go to the first one here, this one is called main circuit breaker. Main circuit breaker. MCP, main circuit breaker. MLO, main lugs only, no circuit breaker. So please, if you get this one, you're good. If you do not get it, you still have 2 chances of getting it in the commercial industry. You're going to hear me talk about main lugs only, main circuit breaker. Here's your meter socket, guys. You bring your hot and neutral. In neutral typically land right in the middle, goes right here. The hot goes into each one of these, in and out, in and out. What they do is they bond the neutral to the box. Right here, this box is actually bonded to the neutral. So they ground the meter socket through the neutral. That's an exception in the code. Only for meters we do that. We'll talk about this one when it comes to the grounding too. Here's the main bonding jumpers, guys. We talked about, can you guys see the neutral here? I want to emphasize the neutral. Here's my neutral. This is my neutral bar or terminal. This is my grounding terminal. And they bond them with this wire. which is called main bonding jumper, and then the ground, take a wire all the way to the ground, which is called grounding electrode conductor. Terminal, and then also they have this little screw to bond it to the frame. So I have service entrance, equipment ground conductor, and neutral conductor must be bonded together, main bonding jumper, and then tied. Can you guys see the green wire? Tie it to the frame, bond it to the frame of that box. These are all requirements for the service panel. And of course, right ahead of it, what you're going to need to do, circuit breaker, like 200 amp circuit breaker. That will be landing on two of them, one on every side. Any comments, any questions, guys? You can put all your neutral conductor in one bar, all your equipment grounding conductor in no more than three of them under one screw for the equipment ground conductor. These have to be a screw wire. Now I'm getting in deeper into the installation itself. That's a major thing. The inspector walks in. How many white conductor are you putting under this terminal? 2, violation. 1, yes, for the neutral. For the ground, you can put 3 of them. Put them under one terminal. For the hot, 1. So unless the log is rated for more than 1, when you have a log on a circuit breaker, you can only land one conductor unless it says you can land 2 or 3. Can you physically put 5? Yes. Is this violation of code? Yes. What happened if you put 5? They get loose. What happened when they get loose? They arc. What happened when they arc? They got hot. And if you're lucky, the circuit breaker will trip. If you're not lucky, they burn the big chunk of your circuit breaker in there. And if you're not lucky at all, you burned your house. So, did you hear where was it a fire last night? Did you guys see? Was it in Minneapolis here? Yeah, I think in South Minneapolis, and they see the electrical. Was it the electrical? Okay, maybe the fire in the East Coast that took part of the coastal area, and they were saying that corroded electrical wiring was the problem. So it's amazing when you guys have a wire sitting there corroded, the insulation is gone, and because of corrosion, the insulation got damaged, and it sits there in arcs, and right next to it a bunch of papers there or some combustible material. You got yourself an ignition. Yeah, the New Jersey. Yep, on the New Jersey shore. Yep. That got burned because they were talking last night because of corroded electrical wiring. And they're asking everybody to go check their electrical wiring after, what's the name of the storm that hit them? Sandy. Yeah, after Sandy's storm. So it's a big deal. So it is a big deal. Okay, sealing. When you come from 2 different temperature, guys, the NEC code book requires you to seal. Can you guys see that here? That seal will prevent the moisture from coming. So when it's in Minnesota, we have 20 below here, degree Fahrenheit, and my house will be, if my wife is there, will be 85 degree Fahrenheit, right? Because she cranked that sucker so high. 85 here, 20 below. What do you think is going to be? That will be a transfer of energy out here. That transfer of energy does condensation here. It'll make condensation, it will burn your equipment. So the smarter than Chad say, you are to seal here. You have to put a sealant here that prevent the flow of air between hot to cold and creating a condensation. Okay, so be aware of that one. That's if you're a project manager, you have to adhere to this one. Okay, this is for your service. This is coming from underground, guys. The service will go right through it. Here's how the conductors come into the underground. For the underground service lateral coming into a meter. Here's how grounding and bonding is all about, guys. This is a really nice picture. I like it because here's my grounding electrode conductor. Can you guys see that? Right in here, my grounding electrode conductor. Main bonding jumper, grounding electrode conductor, my neutral. Can I guys get you to understand that this is all the ground and bonding? You take your neutral, you ground it, and then you ground your box. That's called through a grounding electrode conductor, which is aka a rod or a pipe or a concrete encased electrode or something similar. Any comments, guys? This summarizes all the grounding and bonding at the service. Grounding, or most of the grounding and bonding at the service. Okay, metal raceways between metal boxes, equipment bonding jumper. So you have to, if you have to bond your metal boxes, guys, either with a raceway or with a conductor, metal boxes, equipment bonding jumper. So you have to, so in this case, you have these two equipment, if it's metallic box, they will be bonded through the conduits. If they are non-metallic, then you are to provide an equipment grounding conductor or bonding conductor to tie the two together. Here's all the hardware that you can use for bonding to a pipe, different hardwares that you can use, clamps and so forth. What's in it for you guys when it comes to grounding and bonding? The more hardware you know, the better you will be. Here's a service, guys. I don't know if you can see. I'm going to emphasize the grounding. We're coming from here, and we bonded the neutral to the ground here. And then we went to the water. We jumped around the water, and we also went to the concrete piece electrode, and we went to a pipe. This is, the code requires you to have one, but if you have one pipe, you have to have another pipe to supplement it. Any comments, guys? Any questions about this grounding and bonding and meaning? The second panel, guys, you have, I don't know if you can see here, you feed another feeder here. This is main lugs only. You do not bond the neutral on the ground. Can you guys see? This is the equipment ground conductor. This is my neutral bus isolated in the second panel. In the second panel, not the main, the second panel neutral must be isolated from the box. Can you guys see that? That neutral here, completely isolated from the box. A few requirements about the grounding electrode conductor tie within the first five. Number 6 conductor is the minimum that you can use. Number 4 conductor is the minimum that you can use for concrete encased electrodes. So can I get you guys to fully understand that one? And I know there's a lot of information in this, and I promise you we will be doing grounding and bonding a lot, but the more you understand now, the better it will be in the future as we move through. So that's bringing your service in. Here's another example, guys. We looked at bonding or bringing the grounding. This is bonding water pipes, bonding anything that's not metallic. You can see how all the water, oops, let's use green. All these water pipes plus the gas are bonded together to put them in the same equipotential plane. That's your bonding. Ground rods to ground the system. If you are to use an armor cable, guys, to protect your conductor, if you are to use an armor cable to protect your conductor, you have to bond the armor cable. You have to bond your armor cable. So if you have the equipment ground conductor, it's bare. If you put it in a conduit, you have to bond both ends of that conduit. So this is just a couple of examples how they do them in a conduit or a pipe. Here's how you bond them in both sides, this side and this side for the conduit. I think there's an example where metal raceways containing bare ground conductor. Non-metallic. If it's non-metallic like PVC, do you need to bond it? The grounding electrode conductor in a non-metallic raceway, no need to bond it at both ends. This is the wiring at the second building. Really nice example of wiring the second building, guys. I can't emphasize. Here's what I told you. You need 4 wires for this system. You need a hot 1, hot 2, neutral, and a ground when you feed the sub panel at the second building. You also need to create a grounding electrode system and tie here. Your neutral is completely isolated. Can I get you guys to understand that one? At the sub panel, the neutral is not bonded again. You bond once. So you can see how the bonding happened here once, right? Do you see any bonding between the two here? There is no bonding whatsoever between the two. Right here, there's no bonding whatsoever between the two. Can you guys see that? Versus there is a bonding here. Maybe I should move it. Can you guys see that little bonding, main bonding jumper here? That's only done at the service. Only done at the service. So there's a lot of, we talked about this one, guys, why we ground. This is your gas furnace. your gas furnace above ground gas lines. So if you have a gas furnace, guys, here's my gas line. Can you guys see that? And here's my pipe. So the two are tied together through the frame of the furnace. So you don't need to bond. Can I get you guys to understand that one? When you bring a gas pipe, tie it to one metallic frame and an EMT conduit to the same metallic frame, the metallic frame of the object, which is in this case the furnace, will tie the two together, bond them together. So what they're telling you based on this rule, you don't need to bond to have a wire between the two here. Can you see to bond them together? Why? Because they're bonded through the frame of the furnace. Bonded through the frame of the furnace. Okay, so if you have, here's a good example where bonding become a big deal, guys. You have an EMT conduit going into grounding metal. So here's an EMT, and non-metallic box. Now these two conduits have to be bonded together. So the smarter the chant, they put a bonding bushing here with a wire. Now these two conduits are sitting at the same potential. What's bonding? Sitting at the same potential. Why? Because you don't want to have one conduit have a 120 voltage and the other conduit have 0, and you send chat to the second life. So if they're not continuous, then you have to make. Here's a couple of examples, guys, of bonding bushings and wedges. Bonding bushing here and wedge, different type of wedges where you can bond the conduit itself. So you take a wire from here and you go take to the ground bar and you land it right to the ground bar. And you put your conduits right in here. By doing it this way, now you have bonded your conduits. That's a major topic, guys. Again, I promise you, we'll hit it when we talk about grounding and bonding. We'll hit this one more. Different type of insulation bushings. We use insulation bushing if the conductors are number 4 larger, guys. If you put a big fat conductor and you push it through an EMT conduit, how many of you guys have pushed? You did push a few of them, right? If you push conductor through an EMT conduit, a rigid conduit, as you push these conductor, you will damage the insulation. So especially if the conductors are big. So the code requires you, if the conductors are number 4 or larger, to put an insulation bushing. So a plastic type of bushing to limit when you're pushing it against the metal, insulation against metal, you damage it. If you push insulation against non-metallic, like that bushing, insulation bushing, you would not damage the conductor. So these are required for number 4 or larger, conductors number 4 or larger. And there's some, here's how they do them. You put them right in here, your insulation bushing. So as you pull your conductors, you don't damage the conductors. And you still have bonding. So here's your lock nuts. You have 2 lock nuts, one in, one out. These will bond the conduit to the box. Now you need to protect the conductors as you pull them through. All this information, guys, this is, as I said, this chapter is one of the best chapters you're going to encounter. Will help you residential as well as, this is also commercial industrial. The only difference is voltage will be different. So if you guys understand it and pay some attention to it with what I'm going to add to you, you'll be a good project manager. You will be a good project manager. Okay, this is, I'm going to skip over that one, residential. Okay, so that's that number of rods. When you put your rods, the multiplier that you do them, any secret book guys require you to put rods, 2 rods to supplement each other. Typically you put them, here's rod 1, you go 6 feet, and rod 2. Minimum 6 feet between them. When you put 2 rods, minimum 6 feet between them. Because put them closer together, they're less effective. So they require you to have minimum of, this is the multiplier they use, but typically minimum of 6 feet. Okay, I thought, I don't know if you guys went through this one in the electrical. This is when you put your grounding electric conductor, if your conductor is number 4 or larger, no need to protect it. If your conductor is number 6, only protection if it's subject to physical damage. If your conductor is smaller than number 6, you must put it in a conduit. So that's why most of the time, guys, in dwellings, if you see, what do they use? They use number 6. Why don't they use number 8, even though? If you put a number 8, you know what you're going to need to do? You need to put in a conduit. Seriously? You're going to put a number 8 conductor from the panel into a conduit all the way to the water pipe? You can. If it's number 8, it has to be in a conduit, EMT or PVC. That's why most of the time, even though we can use number 8, we end up with putting number 6, because number 6, you only need a conduit if it's exposed to physical damage. Now, how the heck is going to be exposed to physical damage when it's in my basement, coming from the panel, through the rafters, all the way down? I mean, nobody's going to be messing around with it. If it's on the outside of Dunwoody here, Chad can drive his car into it. That's physical damage, right? So it doesn't, then you can put it without a cable. Otherwise, you have to put a cable over it, like flexible, this armor cable, use an armor cable like this one, um, or you can use a conduit. PVC is the conduit of choice, because then you don't need to bond both ends. So this is a very, very interesting slide. I can't emphasize in terms of insulation. When you size the grounding electrode conductor, this is the table that we're going to use, guys. Very simple to use. You will get sick of me talking about it. If your service conductors are, say, number 2 or smaller, then your equipment grounding conductor is number 8. Now, why don't we use number 8 in dwelling? So if you have a service 100 amp service, you can get away with number 8 conductor. Why don't they use number 8? Have you ever wondered why do they always use number 6? Because to use number 8, you have to put it in a conduit. Pain in the butt. You put it in a conduit as you go to the routing of the conduit, and as you go to the pipe in a conduit. So what do? They use number 6, larger. So number 6, the only time you need to put it in a conduit if it's exposed to physical damage. Meaning, if you grab it, if it's going like I did a job where the grounding electrode conductor went right through the kitchen. Just because where the panels located. So here's the kitchen, and the grounding electrode conductor went right through on the outside, exposed, and number 6 went down. The inspector, when he saw it's in the kitchen, not the basement, so people can move a chair against it. The inspector makes me take it and put it in a PVC conduit to protect it from physical damage. If it wasn't a basement, you don't need to do that. So that's so important that the number 6 or larger, guys, physical damage. And that's all I have. I know it's a lot of information, guys, but I cannot emphasize how important this chapter is when it comes to bringing the electrical energy into your house and powering your building with it. You guys understand, if you understand most of it now, you're good to go as we move on. If it's too much, it will be repeated as we move forward. All this stuff will be repeated from a 3-phase point of view. Does that make sense, Karen? So, but it's this service to you and your customers that you guys are going to be helping when you become a project manager, if you do not ask about the service point. That service point will decide, like we said, wherever your service point is going to be located, it will decide who is responsible for what. That service point is very, very important. Any comments, guys? Any questions? Comments, questions? So that will conclude our service equipment chapter. We will touch on the same information from a 3-phase point of view as we move forward. Just to summarize, guys, when you bring the service, you have to ground the neutral and ground the equipment. Very, very important. Right to the service. You have to decide where the service point is, because based on where the service point is, that will determine which conduits and cables you have to design and install and maintain, and which conduits and cables the utility have to design, install, and maintain. The service point. Comments, questions? It's an involved chapter, big one. So I thought we spend as much time as we can on it. Okay, that's all I have. Thank you.